You people, we are taking too long. If you've finished, you can discuss briefly what you've got, or you tell us your final answer, the enthalpy change for the formation of methane. Then we compare. Members, we are running out of time. Yes, Peter? Peter, can you hear me? Patience, can you hear me?
Yes, teacher.
You are taking too long. What have you got? Jonathan, what have you got? Jonathan, you're not talking.
So it's Peter. I got negative 75 joules per mole. Kilojoules per mole.
Kilojoules or joules? Kilojoules. Okay, so negative 75.
Yeah, kilojoules.
Peter, what have you got?
That's what I got.
That is Peter.
Negative 7. Yes.
Jonathan, what have you got? Eh? Jonathan, what have you got?
Negative 211 kilojoules per mole.
Eh?
I've got negative 211 kilojoules per mole.
I have not heard you well. Patience, what have you got?
Negative 75.
Negative 75. Actually, that is the correct answer. Now, I am going to give you more work, but I want us to go through that question so that we get where you have a problem. All of us should participate in that discussion as we move through it. Now, are we there? Patience, are you there? Patience, can you hear me?
Yes, teacher.
Jonathan, can you hear me?
Yes, teacher, I can hear you.
Okay. Godwin, are you there?
Yes, teacher.
Immaculate?
Yes, teacher.
Okay, Immaculate, are you there? Okay, now let's look at, the question is asking us to get the enthalpy change for the formation of methane, but you are given a thermochemical data. The data we are given is enthalpy of combustion of carbon, the enthalpy of combustion of hydrogen, and the enthalpy of combustion of methane. But we need to know which equation do we have. The equation that we should have as expected is carbon plus hydrogen giving us methane. Now we have the steps that we are expected to use. The first one, we are looking at the enthalpy of combustion of carbon, which is members, you can rejoin. Peter, are you there? Peter, are you there? Patience, are you there?
Yes, teacher, I'm there.
Are you seeing what is on the screen, everyone there?
Yes, teacher.
Okay, now, so
Yes,
these
sir.
are the steps. The first step is for you to write the correct equation for the formation. Remember, we don't mind about the steps, but we mind about the first step and then the final. So we are talking about enthalpy of formation of methane. And for us to form methane, we need 1 atom of carbon, 2 molecules of hydrogen, which means 4 atoms, because hydrogen is diatomic. And then we form 1 mole of methane. So we have been told that the first step has carbon and oxygen. Now you can see that our carbon is on the right side. This first carbon is the same as the carbon we have there. The same state, the same number of moles. Now we can see that we don't have hydrogen because here we have oxygen. Here we have oxygen, but there is hydrogen here. And then we are also seeing that there is a reaction that we have here. Now, the first thing for us to do is to get from here which expression, because now we have been given the enthalpy of combustion of methane, and we want to find a way through which this methane goes to the same side as the other methane. Are you getting me, people? I want you to be very attentive here. Patience, are you seeing that? Patience? Peter, can you hear me?
Yes, sir, I can hear.
Yes, teacher.
Okay, now, I am saying, when you look at this methane,
Yes, teacher.
and then this other methane, they are on different sides, but we want to pull them to the same side. So the immediate thing we are supposed to do to take this methane to the other side is to reverse the equation. So we start by reversing equation 3. We reverse equation 3, and then we add it to equation 1. So when we reverse equation 3, this is what is going to happen. When we reverse equation 3, we start from here. We are multiplying equation 2 by 2. Why are we multiplying? Because we need 2 moles of hydrogen. Are we there? We need 2 moles of hydrogen, and yet here we have only 1 mole of hydrogen. So if we are to get these 2 moles of hydrogen, then we multiply that equation by 2. So when we multiply by 2, we multiply throughout, including the energy content that we have. So we shall multiply 2 moles of hydrogen gas. When we multiply this oxygen by a half by 2, remember we have a half here, we get 1 molecule of oxygen, which we are seeing here. Then we get 2 moles of water, meaning that even the energy, which was negative 290, 85.5, would actually be what? Be increased. That would also be multiplied. Then we reverse equation 3. When we reverse equation 3, remember our heat content here was negative 890. But now when we reverse it, it is going to give us what? When we reverse it, it is going to give us plus now 890. When we add equation 2 to the reversed equation 1, equation 2, which is multiplied, and then the reversed equation 3, we get equation 4. Now, that means that we have this negative 572 plus 889. The difference is what we have here at 318 kilojoules per mole. That is equation 3. But now look at the equation 3. What is appearing? We are seeing hydrogen, 2 moles appearing. We are seeing carbon dioxide appearing. We are seeing methane appearing. And we are seeing oxygen appearing. But what we need is hydrogen, carbon, and methane. Are we there up to that point?
Yes, sir.
Yes, sir.
Are we there?
Yes, sir.
Okay. So I'm saying, because we need, from the original equation, we need 2 moles of hydrogen. And yet in equation 2, we have only 1 mole of hydrogen. So we multiply this one by 2, then we reverse equation 3 because we want methane on the same as the one we have in the expected equation. Then we add the 2. And then we get what we have got here. So that now brings us to equation 4. So when you are putting your eraser there, make sure you remove it. Now, since we have got this equation 4, by adding this energy content plus the other energy content and go to this, then we now want to eliminate carbon dioxide and have carbon and eliminate oxygen. So what do? We then now add equation 4 to equation 1. Where is the equation 1? The equation 1 has carbon, which actually we need in the first equation. Equation 1 has oxygen, which cancels the oxygen in equation 2. Equation 2 has 4 has carbon dioxide, which we have on the side. So you can see that this carbon dioxide goes with the other carbon dioxide. This oxygen goes with this oxygen. Then we can add the rest. So the rest would now be carbon plus 2 moles of hydrogen, and we get it. Then we also add the energy changes. So the correct answer that would give us negative 75 kilojoules per mole, which I think most of you have got. Is it okay? Anyone who has not yet got that one?
It's not yet okay.
It's not yet okay. So can we go through again? Now the problem was calculate the enthalpy change of formation of methane. The first step is for you to get what are the equations that result into formation of methane. From its elements, we have methane plus, carbon plus hydrogen gives us methane in that state. Do you get that, patients? Patients, do you get
Yes,
that?
teacher.
Now, the equations
teacher.
that we were already given are these with their magnitude of the energy. Now, the first step is we want to have the right compounds in their right positions. And remember here, we want carbon on this side. We want hydrogen on this side. We want methane on the other side. Jonathan, what is that? Okay. Now, since now you can see that the equation 2 has hydrogen, but it is only 1 mole of hydrogen, and yet here we need 2. So in order for us to get 2, we multiply equation 2 by 2. Such that multiplying now multiplies the all things that we have here, multiplies hydrogen, multiplies oxygen, multiplies water, multiplies the energy, heat of combustion. Now we are also seeing that there is methane here, but it is on the wrong side. So what we do is we reverse this, such that now we have carbon dioxide plus water, giving us methane and oxygen. And then we also reverse the sign of the heat, which is negative 80. Now it becomes plus 890 kilojoules. That is what we have done in our first step. The first step, you are multiplying equation 2. The purpose of multiplying is to get 2 moles of hydrogen. And that also multiplies oxygen, because the other original equation was a half. Now this one becomes 1 mole. Then we are also multiplying this, and we multiply the energy. Now, since we have reversed this, when we add this, it is going to give us a new equation, which is equation 4. That equation should have the energies. This is plus 890, then the other one is minus 572. When we add them, it gives us now plus it is actually positive. It gives us plus 318 kilojoules per mole. Now, because we have now got this, and yet we have carbon dioxide and oxygen, which must be eliminated, and also introduce carbon on our left-hand side. What we have now done here is to now bring equation 1 that has carbon. Now that equation 1, remember, has carbon, has oxygen, has carbon dioxide. So when you add this equation 4 to equation 1, you can see that the carbon dioxide on the left-hand side cancels the carbon dioxide on the right-hand side. You can see that the same number of moles of oxygen on the left-hand side cancels the oxygen on the right-hand side. And what we remain with is the hydrogen, what we need, 2 moles, which we have here. You have carbon, which is what we need, and you have methane. Then overall, you add this energy content to what we have for the combustion of oxygen. And then once you add them, you get a full equation for the formation of methane. And our total energy, remember, by Hess's law, is the sum of those energies. And that's why we have got 75 kilojoules more. Okay, maybe for the last time, in case you are disconnected, again, reconnect because of the network and then the limitation. We have to reconnect after every 40 minutes. Questions, have you got that?
Yes, teacher. Thank you.
Yeah, now we are going to give you, I'm going to give you 2 more questions, which you are going to copy, and then you will do it. And probably the answers can be there tomorrow, or you can do and take a photo and post it on our WhatsApp platform. And the questions are,